Hello. So in the last video I showed my process for creating, rigging, and animating the 3D player model that we'll be using for our player controller, and we got it imported into Godot. In this video I'm going to actually begin constructing my player scene so that it can act as a sort of prefab for me to drag and drop into any scenes that I want a controllable first-person character for. So to start out simple, I just want to be able to move the character around with the WASD keys and move the camera around with the mouse. Alright, so I'm here in Godot, and this scene right here is going to be our player scene, and then this new scene right here will be our test environment. So I'll just go ahead and save these. Save this one as player, and then I'll save this one as test environment. Alright. So now in our test scene, I'm just going to go ahead and add a CSG box. And then I'll stretch it out to be a floor by adjusting its size here in the inspector. Alright, and now we're going to add a static body to the floor so that our player physics body can interact with it. And to this we're going to attach a collision shape to determine where physics collisions can occur. Now I'll just create some obstacles the same way. I'll just copy and paste the floor and adjust the size. Make sure if you copy and paste like this, you remember that they are both sharing the same box shape resource for the collider. If you copy and paste it and adjust the CSG box size, you'll need to create a new box shape for any boxes with a different shape. Otherwise, if you change the size of one, it'll change the size of the box shape for all objects sharing that collision shape resource. Now I want to throw a basic grid texture on these objects. I'll go to wahuni.itch.io texture grid generator, and I'll make a white grid texture, then click save. I'm just going to drag and drop the texture PNG into the resource bin in Godot. Now to use this texture in our scene, I'll create a new standard material 3D. And I'll just save it as grid material. Then here in the material settings, I'll click down the drop down for albedo, and I'll drag and drop the texture. Now I'll just drag and drop the material onto our floor and see how it looks. Since we saved it as a white grid pattern, we can go back to this color wheel in the albedo section and select any color we want. Right now the texture is mapped so that it covers the whole surface, but we want the texture to tile automatically with the scale of the object so that we can get a good sense of scale in our game world. To do this, we can just scroll down to UV1 and select triplanar mapping. Now if you want, you can copy this material with any color you want and attach it to other objects in your scene. Alright, so now I'm going to start working on the player scene. First I'll import the player model into the scene. I'm going to start by adding a camera to the scene. I'll align it to the camera bone that was imported with the model. It shows me exactly where I place the camera in Blender. Also, I don't think that I said this in the previous video, but I placed the camera slightly in front of where the head would be so that when it rotates downward, you see the front of the body and not inside through the neck hole. So in case you have a special case for your game, it's likely that your game will contain physics calculations, and therefore it makes sense to move your character around the world as a physics body. There are several types of physics bodies in Godot. I'm going to go ahead and add a character body 3D to the scene, and I'll make my player a child of that. And now we need to add a collider so our player doesn't fall through the floor. I'll go ahead and edit the capsule shape to fit my character. And I guess I'll just go ahead and save this capsule shape as a resource so I can reuse it. Now for the camera, I already know that if I'm going to have the head rotate independently from the body, the camera should not be a child of the character body. So what I'm going to do is set up a node 3D here, which will be the camera base, and control the camera's yaw movement. Then I'll add another node 3D as a child of this, which will inherit the base's yaw rotation and control the camera's pitch. Then I'm just going to create a new player group node to group them into one object. Nice. Now before I start working on the code for the player controller script, I have to define all my inputs in Godot's input action map. Just go up to Project, then Project Settings, and then Input Map. I'll start defining all my actions here. Then I can go ahead and assign each key to each input action. Now that that's all set, I can go to the script editor and I'll start going over the code for the player controller. There are many tutorials on GDScript and basic scripting in Godot, so instead of explaining each and every step of the coding process, I am going to briefly cover parts of the code in modules. So right here is a super basic script that just handles the inputs and stores them into variables. Up here I start by defining some variables. I got my constants like move speed, jump force, mouse sensitivity, and then we got our gravity from project settings. Then I define some global variables like our mouse delta, movement input, and jump input. Then here in the engine's input function, which gets called every time there's input, I'm going to call these three functions that'll handle mouse input, movement input, and then I'm also going to capture input for a toggle mouse mode option, so I can hide or expose the cursor whenever I want. Then I define three input handler functions down here. In the handle mouse input function, if the input event is mouse motion, we store the motion data in mouse delta. Here in the handle movement input function, we are just storing the isActionPressed boolean for each movement direction in a vector3 variable and normalizing it so that it represents the movement direction. And then in the handle mouse mode input function, we just say that if the input event is hide mouse and if the current mouse mode is captured, then set it to visible and vice versa. So now that I've set up basic player input handling, I'll go ahead and set up the basic movement and camera rotation. Here I've added node references to the camera base and the camera pitch nodes. Here I've defined the maximum pitch angle for the camera at plus and minus 89 degrees. You can pick whatever you want, I just like those numbers. These are a bunch of global variables to store the input data. And down here we have added Godot's physics process function, which is called every physics frame. This is where we are going to rotate the camera and move the player. Down here I've defined the handle camera rotation function and rotate the camera base by minus mouse delta x times mouse sensitivity times delta. This delta value represents the time elapsed since the last physics frame, and it is used to keep your physics base code consistent across all frame rates. Now I'm just going to say right now that there's a whole rabbit hole you can go down on how to properly apply this delta value to the functions in your game to achieve this. There are really interesting formulas that you can use that are a little bit more than just multiplying your value by delta like we're doing here, but since our project is small, I'm not even going to think about that right now. For now, this value just helps out with smoothing out the movement. Then I clamp the X rotation, the pitch of the camera, by the min and max we defined earlier. Then we reset mouse delta to 0 after doing the rotation so the values don't continue to accumulate. Over here in the handle movement function, we define the forward and right directions of the camera base. Right now, if we move the character body with the raw movement input, the direction of movement would be in relation to global space. And for a first-person game, we would want the player movement to be relative to the camera direction. Then we check if the player is grounded. Then we calculate the player's desired movement direction by combining the camera direction with the move vector like this. Then we multiply it by the move speed we defined and set the character body's x and z velocity to this. For the y velocity, we accelerate the character body downwards by the gravity constant we defined times delta. Lastly, we check to see if the jump button was pressed and the player is grounded, and if they are, we reset the character body's Y velocity to the jump force we defined earlier. Then we finally move and slide the character body. Now let's go ahead and try this out. I'll go ahead and drag and drop my player scene into my test environment scene, and then build the game. And well, everything technically works, but you can see that because I didn't want to make the camera a child of the character body, the camera doesn't follow the player around when they move. No problem though, all I have to do is go up here and define these two variables, which gives me the starting position of the camera relative to the character body, where it's supposed to be. Then I just add this line down here after move and slide. This adds the camera relative position vector to the character body's origin vector, and then rotates it around the character body's y-axis by the character body's y rotation. Now when we start the game, look at that, camera stays where it's supposed to be. So now that we have basic movement set up, in the next video I'll get started on handling the player body's rotation, because as you can see right now, the player's body always faces the global Z direction right now. And after that we'll get started on setting up the animation tree and having the player hands track the camera's rotation. Thanks for watching.